Now we're recording.
Okay. All right, Professor. So we're going to try to explain the code we have. So this one is for the object detection. And so we are using a data set that contains images of food items that we collected. So we are trying to classify between having
Donuts and
donuts or
omelets.
pizza,
Donuts and omelets.
donuts and omelets. And so we are using TensorFlow, Keras, CNN, and here we show basically how we set up the classifier. So we have the sequential, the convolutions, um, and then flatten is used to sum up all the outputs. And for the loss function, we're using the binary cross entropy, and to measure the performance metric, we're using the accuracies. And then this is just to set up the classifier. Um, and this basically allows to recapitulate the picture, so it tends to reduce the level of error. And here we basically are uploading the training and test set.
We're making sure everything
So
is retargeted to a proper power of 2 square, and 64 by 64 is a typical value that's normally used for a situation like this. Could also do 128 by 128, but the power of 2 allows it to maintain a square shape. So when it does the layers, it'll always have a consistent matrix size for any in image. And here we are just running 20 epochs, and we had to run that the length, or the steps we run at the length of the actual test set, of the training set, and then the validation steps we're running at the length of the test of the test set for the validation steps, and then we're feeding back to our tensor board so we can log out the graphs which we've put in our paper. And then for classifying it, I give it a random test image, and then it attempts to test it out by just converting that image into a proper NumPy array, and then it will tell us whether or not it's an omelet. And so here we can see that we're properly loading up all those libraries, that we're running on the steps of the epochs. So we can see our accuracy is gradually increasing from somewhere around 20%, or 70%, increasing, pushing that 70 to 80%. On this step, on the 5th epoch, we got like 90 a couple of times, and as we go down, we're popping between the 70 and 80 range, getting the occasional 60 there, and then this time it had a 100%. Oh, that was kind of interesting how it got that. And then we just keep scrolling down through the epochs. We'll go ahead and just go to the bottom. And so our test image, which was a donut, as we have here, it did classify it properly, stating that it was a donut, with our accuracy peaking around 94, and our validation loss being around 61, and the validation accuracy being around 78. So, anything else, Farid?
No, I think we'll be good for this. Can we be able to show the phase detection one, or?
Not with my performance. So in the face detection, we were able to detect things, but due to the complexity of that running code, it is too expensive to record on my machine and run it at the same time. It is using up the majority of my machine's power, and I'm not able to record and run it at the same time without getting errors in the running of the code.
But Professor, we will be able to put in the source code, and also we have a result that we placed in our paper. So it does is the phase detection one that we're using is able to classify between whether the image is that particular label or not. So in our situation, we used the picture of Donald Trump, and we provided more details in the paper. Is there anything else, Chris?
I believe that's it. We will be able to show the facial results in the paper, like Farid said, so those results come out cleanly. And I believe that is all for now.
All right, thank you.